Hello? 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 If I'm audible, you can write it in chat box. Hello? Hello? All right. You can tell others to join. All right, let's start with the first question. See, we will solve chapter 6 MCQ of physics, that is electromagnetic induction. We will solve the MCQ type questions. Question 1 is a square loop of side 1 centimeter, sorry, it is 10 centimeter, and resistance given is 0.5 ohm is placed vertically in east-west plane. In east-west plane. Then uniform magnetic field set up across the plane in northeast direction. 0 point magnetic field 0.1 Tesla in northeast direction. If magnetic field decreases to 0 at a steady rate of 0.7 second, if magnetic field reduced to 0 at steady rate of 0.7 second, the magnitude of induced current in loop will be magnitude of induced current in loop you have to find out. Okay, options are given 1, 2, 0.5, 1.4. 1, 2 milliampere, C 0.5 milliampere, and D 1.4 milliampere. Okay, try to solve it out. I hope question is visible. Okay, anyone got the answer? Okay, Rudra got the answer. Anyone else? Okay, let's see how we can solve this question. See, first of all, here side is given. So from that you can find the area of 0.1 square, that is 10 power minus 2 meter square. Then resistance R is given 0.5 ohm. After that, but see, this is in east-west direction and this is in northeast direction. So basically, so theta will be equal to 45 degree. From this you can find. Then value of B is 10 power minus 1 Tesla. Now first of all you can find flux. Flux you will get BA cos 45. BA cos 45. This you can find out. Again a delta T is given. From this you can calculate the flux. Then delta T is given. So from this I is equal to, you can write out 1 by R is into d phi by dt. This you will get from here. Dt is given and 1 by R you need to divide. You will end up getting the answer 2 milliampere. Okay, I hope it's clear. Everyone, is it clear? Is it clear? Hello. All right. Let's see the next question. Let's see the next question. In that time varying magnetic flux is given 5t square minus 4t plus 1. 5t square minus 4t plus 1 time varying magnetic flux is given. So magnitude of induced EMF at t equal to 2 seconds. So you have to find magnitude of EMF and induced current at t is equal to 2 seconds. This you need to find out. Resistance is given 2 ohm. Okay, value of resistance is given 2 ohm. Options are 16 volt 8 ampere. Second is given 12 volt 6 ampere. And third is given 16 volt 4 ampere. And fourth is given 8 volt 4 ampere. This is easy. Anyone getting the answer? Option A. Okay. One response I received, that is option A. Anyone else? Okay, option C. One response I received is option C. Okay, option A, option C. So students are confused between option A and C. Okay, let's solve it. See here 5 is given and we need to find induced EMF. So formula is d phi by dt. Magnitude of induced EMF is d phi by dt. So you need to take the derivative of this. So differentiation of 5t square minus 4t plus 1, it will be 10t minus 4. Now at time t equal to 2 seconds, you need to find out for t equal to 2 seconds. So it is 10 into 2 minus 4. So answer will be 20 minus 4, 16 volt. So this one is correct. Either A or C will be the answer. Now if you want to find the induced current, so it is magnitude of EMF upon resistance V by R. From this you can write 16 upon 2. So current will be 8 ampere. So option A will be the correct answer. Those who have given A is the correct one. Okay, any doubt? Anyone? Anyone having doubt? You can ask. All right. Let's see the next question. Let's see the next part. Question 3. total charge induced in a closed circuit of resistance R, in a closed circuit of resistance R, when magnetic flux delta phi changes with time delta t depends on. So I'm writing the factors, on what factors it depends. Rate of change of flux only, that is rate of change of flux only. Option B, it is resistance and total change in flux. Resistance and change in flux. Then option C, time interval only. Time interval delta t only. And fourth, both resistance and time interval. Resistance and time interval. Very interesting question. Try to solve. Okay, option A, B, A, B. All right, so in this A and B, they are in target. Okay, A and B, they are in doubt. Okay, anyone else? Any other option? Can you type the logic why you are saying A or why you are saying B? Okay. Okay, let's solve. Let's solve. See, we know formula of I, that is 1 by R, rate of change of flux upon time. Here one more extra thing they have asked, that is charge. Okay, यूजुअली हम क्या करते हैं, हम ईएमएफ और करंट उसके साथ डील करते हैं. इस क्वेश्चन में पूछा है चार्ज. सो वी नो द फॉर्मूला I is equal to delta Q, or you can say Q by T, charge upon time. So here if you place this or compare this, charge upon time 1 by R delta phi by delta T. So this you can cancel out. So Q will be delta phi upon R. So it is rate of change of flux and resistance. So option B will be the correct answer. Okay, option B will be the correct answer. I hope it is clear. All right. Okay, let's see the next question. Let's see the next question. A metallic rod of length 1 meter. Question 4. A metallic rod of length 1 meter is rotated with the frequency 50 revolution per second. Is rotated with frequency of 50 revolution per second about an axis passing through one end and perpendicular to the rod. About an axis passing through one end and perpendicular to rod. Magnetic field 0.2 Tesla parallel to the axis. Magnetic field 0.2 Tesla is parallel to parallel to the axis. Find induced EMF. जो भी EMF बनेगा that you have to calculate. 31.4 volt options are 31.4 volt. Option B is 62.8 volt. Option C 15.7 volt. And option D 100 volt. Solid, very interesting question and very important too. Can you write the formula? Why you are getting A or why you are getting B? Okay, now you are getting C. Flux, and then you have to use the formula with n number of turns. But here see, turns are not there. No need to use that. Yes, very good, Harsh. That is the correct formula. We have derived the different you can say forms for this equation. B is equal to 1 half, sorry, epsilon is equal to 1 half B omega L square. But here you can see frequency is given. Okay. So 1 half B into 2 pi F into L square. So you can cancel this. So B into pi into F into L square. I hope all these values are there. So you can put and check the answer. Put all these values and try to find the answer. L length of rod is 1 meter. So you can omit it. And 0.2 into 50 into pi. So pi will remain. So that is 31.4. Let's see one more such question. A wheel with 10 metallic spokes, each of 0.5 meter length. A wheel of 10 metallic spokes, each of 0.5 meter long, is rotated at a speed of 120 revolution per minute. At speed of 120 revolution per minute in a plane normal to horizontal component of Earth magnetic field. In plane normal to, I am writing directly, Earth magnetic field, 0.4 into 10 power minus 4 Tesla. 0.4 into 10 power minus 4 Tesla. Induced EMF between the axle and rim of wheel. Induced EMF between axle and rim of wheel. See, this is for example a wheel. So these all are called as spokes, and this outer circumference, it is called as rim. So that EMF you have to find out. It is 6.28 microvolt. 6.28 microvolt. Option B given is 62.8. Be careful over here. Microvolt. Option C given is 31.4 microvolt. Option D given is 3.14 microvolt. So solve it carefully. Same formula, using the same formula, you can try this question. If anyone getting the answer, you can tell. 6.28. Okay, 10 power minus 5. You can adjust the power because see micro are given in the question, sorry, in the option. So accordingly you can adjust and tell me the answer, whether it will be 6.28 or 62.8. Adjust and then you will tell me the answer. Okay, very good, Rudra. B is the right answer. Only one thing that you have to take care in this question, that is, see, whenever frequency is given like this, okay, 120 revolution per minute, you have to convert it. 1 minute is 60 second, so 120 revolution upon 60 second, so frequency here will be 2 revolution per second. This value you have to take and then you can place it in the previous formula जो last question में हमने use किया था. Okay, epsilon is equal to b into pi into f into l square. इसी में रख दो तो आंसर आ जाएगा. Okay, clear है? Let's solve the next question. An average induced EMF of 24 volt. An average induced EMF of 24 volt produced in a coil when current in it changes from 5 ampere in one direction to 5 ampere in opposite direction. Very good. Induced EMF produced when current changes from 5 ampere in one direction to 5 ampere in opposite direction. Time given is 0.1 second. In 0.1 second, find self inductance. Okay, that is the value of L. Options given are 0.24 Henry, 0.24 Henry. Option B given is 0.48 Henry. Option C given is 0.12 Henry. Option D given is 2.4 Henry. Try to solve it. Okay, anyone getting the answer? Option A. Let's see. Anyone else? Only one answer I got. Sorry, two. Okay, three students have given answer as option A. Okay. Option D, D भी आ रहा है, option B भी आ रहा है. Let's see. 0.24 Henry. Okay, he's saying option A. Let's solve it. See, for this induced EMF is equal to L di by dt. So induced EMF given is 24 volt. It is equal to L into change in current 5 ampere from one side to other side. So total change will be 10 ampere. Time given is 0.1 second. So it will be like 24 is equal to L into 100. So value of L will be 24 by 100. So it is 0.24 Henry. So option A is the right answer. Very good. Cheers. Okay. Any doubt in this? Okay. Let's solve the next question. A long solenoid of length 50 centimeter. A long solenoid of length 50 centimeter, radius 2 centimeter has 500 ton, and radius 2 centimeter has 500 tons. Self inductance of solenoid in vacuum. You have to find self inductance of solenoid in vacuum. Okay, mu naught is 4.10 power minus 7 Tesla meter per ampere. Options are 0.79 millihenry, 0.79 millihenry. Option B given is 1.58 millihenry. Option C is 0.39 millihenry. Option D is 3.14 millihenry. Try to solve this. You are having the notes, you can use the formula. You can use the formula. Okay, option C. Okay, I'll give you a formula. Self-inductance for solenoid. You can derive mu naught n square A. So here mu naught n square by L square into pi r square. All these values are there in a question. You can put and find the answer. Yes, option A is the right answer. You just need to put all the values and you can get the answer. Perfect. Option A is the right answer. Let's see the next question. See, to solve these MCQs, you need to remember the formula. Simple as that. Okay, let's see one easy question. Energy stored in an inductor energy stored in an inductor of inductance 50 millihenry of L equal to 50 millihenry carrying a steady current of 4 ampere, carrying a steady current of 4 ampere, 0.1, 0.4, 0.2, 0.8, 0.1, 0.4, 0.2, 0.8. You can quickly solve this question. You know the formula of energy stored. You know this formula, energy stored in an inductor. You have derived it. Okay, two answers I got. No, it will not affect. The number of spokes will not affect because they all are in parallel. And in chapter 3 we have studied that cells connected in parallel, the net EMF will remain same. That's why it won't affect. Okay, everyone getting option B. The easy formula that you have used, 1/2 Li square. The easiest question of till today we have solved in this session. Let's see the next one. A pair of adjacent coil has mutual inductance of 1.5 Henry. A pair of mutual inductance of 1.5 Henry. Okay, pair of coil of mutual inductance 1.5 Henry. If current in one coil changes from 0 to 20, if current in one coil changes from 0 to 20 ampere, in how much time it is? 0.5 second. in 0.5 second. The change of flux linkage with other coil. Change of flux linkage in other coil is blank. 15, 30, 45, 60. 15, 30, 45 and 60 Weber. These are your options. Okay, option D, one response. Okay, any other? It is easy question. Anyone else? Okay, option B, 30 Weber. Okay, option B again. See, what is the formula to change the flux depends on M, okay, delta I. This is the simple equation. So M is given 1.5 and change in current is 20. So answer is 30 Weber. Simple. Any doubt? Simply you can solve this. Okay, let's solve last question of today. Or want to solve more? ज़्यादा करने? How many more questions? You say? Question 10. Conductor of length 0.4 meter. A conductor of length 0.4 meter moves with a speed of 10 meter per second. Moves with speed of 10 meter per second. Perpendicular to magnetic field of 0.5 Tesla. Power required to move this conductor. Power required to move this conductor if resistance is 2 ohm. Option A, 1 volt, 2 volt, 5 volt. Sorry, 1 watt, 2 watt. Then C 0.5 watt. And D is 4 watt. We have derived the equation for the power using two methods, mechanical way and electrical way. It's raining good. Okay, getting option B. Okay, option B. All right, option B. Everyone getting option B? Nice. Power is B square S square V square by R. It is formula of V square by R. So V, that is voltage. उसके बदले हम रख देंगे BLV, that is motional EMF. You will get this equation B square S square V square by R. Very good, perfect, Rudra. Very nice. So option B will be the correct answer. That is 2 watt. Okay. Now want to solve more questions. We're done for the day. I'll keeping up to you. Reply in chat box quickly. Okay, one is still in. Want to solve more? Okay, let us erase the board till then. और solve करने हैं, बताओ फटाफट. Okay, only one question more. ताकि 11 हो जाए. Okay, let me give you one more. Those who want to solve. Question 11. When a current in coil changes from plus 2 ampere, okay, current change given is plus 2 ampere to minus 2 ampere in a time of 0.05 second. 0.05 second. Okay, more 2, 3. Let's see. An EMF of 8 volt is induced in neighboring coil. EMF of 8 volt induced in neighboring coil. Okay. So what we need to find? We have to find the mutual inductance. Find mutual inductance. This you need to calculate. Option A is 0.1 Henry. 0.1 Henry. Option B is 0.2 Henry. Option C is given 0.05 Henry. And option D is 0.4 Henry. Try to solve this one. Directly you can apply the formula for mutual inductance. Anyone getting the answer? Okay, option D, 0.4 Henry. Okay, let me tell you the formula. Epsilon is equal to M di by dt. Everything is given. Here you need to take care what current change you will take. Okay, what current change you will take, that you have to take care. Di. +2 एम्पियर से -2 एम्पियर, तो कितना चेंज होगा करंट? ओके, दैट विल बी चेंज ऑफ 4. Yes, very good. 0.1 Henry will be the answer. Option A. Put all these values, you will get the right answer. Okay, so option A is the correct one. Okay, let's see one more. Question 12. Magnetic field of 2 into 10 power minus 2 Tesla. B is given 2 into 10 power minus 2 Tesla. Act perpendicular to coil. Act perpendicular to coil having 100 tons. These are the number of tons given in coil, and area of 100 centimeter square, and area 100 centimeter square. If magnetic field falls to 0, if magnetic field falls to 0 in 0.01 second, then you have to find the induced EMF. Find induced EMF. Options given are 1, 2, 0.2 and 20. 1, 2, 0.2 and 20. 1, 2, 0.2 and 20. This is the first formula of the chapter, जहाँ से Faraday's law हमने पढ़ा था. Directly you can use that equation, but you have to consider n as well. Very good, Harsh. Very good. 2 options I received. Option B. I hope you all are knowing the formulas now. You are solving very quickly now. Okay, so that is a very good sign. Induced EMF is equal to, you can write n d phi by dt, and here n d by dt of B into A. So you have to take A out, change in magnetic field upon time. These all values you are having, you can put value of B. B is this minus 0, so it will remain 2 into 10 power minus 2 only. Time is 0.01, that is again 10 power minus 2. You can cancel it out. Value of n is 100 and A is 100 centimeter square, so it is minus 4 meter square you have to take. Okay, very good. Okay, done or more? Done or more? Deal, no deal? Still you solved good number of questions, that is good. Okay, let's keep it up to here. You can enjoy your off time. I will give you a few more questions to solve. Okay, and still if you want to solve more right now, you can tell me. ज़्यादा करने हो तो बताओ फटाफट. Comment fast in a chat box. because I am having ample number of questions with me. Okay, let's keep it up to here.